On this video, I'll be doing grade 11 redox correction practice questions. Without wasting any time, I'll go straight to the lesson. So whenever you're dealing with this topic of redox correction, it's very important to know we've got two tables which you guys will be given. Is table 4a and table 4b. So those two tables have got what we call half reactions. So always remember that all the half reactions which you are getting, they are all in reduction potential. So meaning if tomorrow they were to ask you to find a half reaction for oxidation. So to find a half reaction for oxidation, the one that is given here is already in reduction. So to find the one that will be representing oxidation, you just need to go and reverse the reaction. Let me just show you for example. Let's say you're going to use F2 plus 2E forming 2F. That reaction that is given there, it's in reduction manner. So if F of fluorine was undergoing oxidation, therefore the oxidation half reaction will be 2F minus, and then you're going to put one arrow there, and then you're going to put F2 there, which will be F2 there as gas, and then you're going to put plus 2E. So this reaction will be what we call an oxidation half reaction. The one that is given here will be the reduction half reaction. So if fluorine is undergoing reduction, your reaction will be in that way that is written there, but only with one arrow there. If fluorine is undergoing oxidation, that will be your half reaction. So just go and reverse it for oxidation. So, and then always make sure that the element that they're doing, if they're doing silver, for example, silver is Ag, you go and look at Ag half reaction there. If they are giving example of lead is Pb, you go and look for that half reaction of Pb there. If they are talking about aluminium, you go and look for aluminium half reaction, which is that one. So depending on the given example, you can go and look for all different half reactions in the table. So let's try our first example. Let's say we are given a balanced redox reaction, and then the telling us that it's copper, then it's written with 2Ag plus, and then it's forming Cu2 plus and A2Ag. So first thing first, you must now ask yourself, between Cu and Ag, who's undergoing oxidation, who's undergoing reduction? So as we know, oxidation is what we call loss of electrons. The reduction is the gaining of electrons. So with oxidation, you can go from 0, for example, and then you go to 2 plus. That's going from 0 to 2 plus. When you're dealing with ions, every time when you see plus, you must know that plus represent what you call loss of electrons. So whenever you see plus, it represents loss of electrons, but minus will represent gaining of electrons. So if an element is undergoing from having a charge of 0 to a charge of 2 plus, therefore that element would have lost 2 electrons. Whenever they lose 2 electrons, we call that reaction, or that element is undergoing what we call oxidation. But for reduction will be the gaining of electrons, meaning now you can start with having, let's say we start with having 2 plus now. Now I'm having 2 plus, which was the loss of electrons, and now we're going to 0. So I'm going from losing 2 electrons, but to 0. 0 is neutral. Therefore, that element would have gained 2 electrons for it to go back to neutral, because it had lost 2 before, but now it's going to 0, meaning that element is undergoing reduction, which is the gaining of electrons. In other words, under reduction, you can have someone on the left having 1 electron, but on the right, they have 2 electrons, meaning they have gained an electron. That will be reduction. The other way you can represent this one is to have 0 on the left, and then on the right you can have 2 minus. Remember, minus represent gaining of electrons, meaning this person would have gained electron because it had 0 here, but it has got 2 minus, meaning it has gained 2 electrons. Whenever you see 2 plus, it means that person or that element has lost 2 electrons. So for whenever something is undergoing oxidation, it will go from 0, then it will form 2 plus on the right side. But for reduction, it can go from having 2 plus, then forming a 0. That will be undergoing reduction. So I hope that will be helpful for you guys before we do examples. So let's go to the question. We're given Cu and Ag, and then they are forming products on the right side here. So let's figure out who's undergoing oxidation, who's undergoing reduction. Let's start with Cu first. Cu on the left, it's Cu there, and then it's a solid there, and then on the right Cu, it's forming Cu2 plus. On the right, C is forming 2 plus. So now you ask yourself, here we're having a charge of 0 because there's no number. So we're having a charge of 0 or neutral charge. So on the left, it's having a neutral charge there. But on the right side, it's having 2 plus, meaning in other words, copper is going from 0 there to form 2 plus on the right. And what do we know? If we go from 0 to 2 plus, therefore you're undergoing oxidation. So in other words, copper is undergoing oxidation. Now let's test Ag. So on the left we had 2 Ag. Check the ion, it's plus there. So meaning we're going from 2 Ag plus. On the right side, it's forming 2 Ag. Now let's check the charge that it's having. On the left, it's having plus charge or plus 1. That means plus 1. But on the right, it's having a 0 charge because there's no charge there. So meaning it's a 0 because there's no charge there. Meaning it must be a 0 charge. So Ag is going from having a plus 1 on the left, forming a 0. And similar to this example, where we go from plus forming a 0, meaning Ag or silver is undergoing reduction. Just be careful of such. So meaning silver is undergoing reduction. That would be silver. It's undergoing reduction. So I figure out now who's undergoing reduction and who's undergoing oxidation. So copper, I'll just put an O there, that we can know that is undergoing oxidation. Ag, I'll just put an R because it's undergoing reduction. Sharp. Let me just erase this so we can do the questions now. Now already I know who's undergoing oxidation. I already know who's undergoing reduction. So let's do the questions as they're asking us. 7.1.1, they're asking us now, define oxidation. Okay, oxidation is the loss of electrons now. So whenever you see the word define, oxidation is the loss of electrons. That is the loss of electrons. That's oxidation. Is the loss of electrons. Is the loss of electrons. That's oxidation. Is the loss of electrons. E minus, which means electrons. So it's the loss of electrons, which is E minus. So whenever you see the word oxidation, that's the loss of electrons. But reduction is the gaining of electrons. So if tomorrow they ask you about reduction, reduction is the gaining of electrons. Now from the balance equation above, write down the reduction half reaction. So now, who's undergoing reduction? Don't forget, who's undergoing reduction? It's Ag. So we know that Ag is undergoing reduction based on what we proved before. Ag is undergoing reduction. So meaning the reduction reaction must be for Ag because we know that Cu is undergoing oxidation. So they want us to find the reduction half reaction. So you go to the table now and you must go and look for Ag on the table. So you must go to the table and look for Ag. So you need to go to the table and look for Ag. So let me just go to the table now and look for Ag. So you need to go to the table and look for Ag. There we are. I found Ag. So the reactions which are given to us on the table, they're already in they're already in what we call reduction half reactions. So they're giving us reactions that are already in reduction manner. So meaning you just go and copy it as it is. So for Ag, we've got Ag plus on the left there on the table. I'm in the table that I showed you guys, the 4A I showed you guys before, and then plus E minus. And then don't forget, when you put them here as half fractions, you put them with one arrow, and then here it's forming Ag. This will be the reduction reaction of Ag. But just be careful. If we had found out that Ag is undergoing oxidation, for example, the oxidation reaction would have been like this. If they ask us to find Ag, which is undergoing oxidation, the reaction would have been Ag will start first, and then on the right you would have put Ag plus. So just go ahead and reverse the reaction, and then plus E minus. That would have been an oxidation reaction of Ag. But because here we know that Ag is undergoing reduction, that would be our answer. But if we had known that Ag was undergoing oxidation and the question was asking us for oxidation half reaction, then the answer would have been like that. But because now we know that Ag is undergoing reaction, therefore our answer will be like that. So just go to the table and copy it as it is. So they didn't ask us for the oxidation half reaction. Let me just put also a reaction for oxidation. So we know that Cu is undergoing oxidation. So therefore the reaction now it will be, I'm going to do one for where Cu is undergoing oxidation. So it will be Cu, then I'm going to put S, and then the arrow will be there, and then you're going to have Cu2 plus there, and then plus so the plus 2E there. That will be your oxidation half reaction, which will be for copper. They didn't ask for it in the question, but just in case if tomorrow they want you guys to find the oxidation half reaction, this will be the oxidation half reaction. Then this one is the one that they're asking for, which is the reduction half reaction. So that will be that. For this one, the answer will be just be this one. This one will be for oxidation half reaction, in case if they were to ask you guys in the next exam or test. Okay, 7.1.3, formula for the reducing agent. So always remember the reducing agent, I'm going to quote RA now. The reducing agent is the person who's undergoing oxidation. So the reducing agent is the element that is undergoing oxidation. That is the reducing agent. Whoever is undergoing oxidation, that element becomes your reducing agent. So in other words, the oxidizing agent, because what we're going to ask you guys also for oxidizing agent. So the one oxidizing agent is the one that is undergoing reduction. The element that is undergoing reduction, that is your oxidizing agent. So the element that is undergoing reduction, that's your oxidizing agent. So now you ask yourself now, between the two elements Cu and Ag, who's undergoing oxidation? We know it was Cu who's undergoing oxidation, meaning now Cu will become the reducing agent. Cu becomes the reducing agent because it's undergoing oxidation in our reaction. So meaning if tomorrow they ask you what is your oxidizing agent, it will be the one who's undergoing reduction, and Ag is undergoing reduction, meaning Ag would be our oxidizing agent. So whoever is undergoing oxidation, that is your reducing agent. Whoever is undergoing reduction, that is your oxidizing agent. So explain your answer in 7.1.3 by using oxidation and numbers. So it's the same thing that I just mentioned. We know that Cu is undergoing oxidation, so meaning Cu will go from 0 to form 2 plus now, based on the oxidizing half reaction. So meaning Cu will go from 0 based on this reaction. Cu will go from 0 forming 2 plus. So meaning that will be your answer for that one. So we know that if you're going from 0 to 2 plus, therefore the oxidizing number will increase now. So the oxidizing number will increase because you're going from 0 to 2 plus. So the oxidizing number will increase because you're going from 0 to 2 plus. So the oxidizing number will increase. That should be your reason for that. Or you can also say that the reducing agent is the one that is undergoing oxidation. So meaning it will go from 0 to form 2 plus. So that is that for 7.1.4. Okay. Now let's go to 7.2. The following incomplete chemical equation represent a redox reaction. Okay, we're given a reaction now. We've got CRuO72 minus reacting with Fe2 plus, then it's forming Cr3 plus and Fe3 plus. That's our reaction there. Then we're being asked to find the oxidation number of Cr in that given number. So remember, check the charge. Charge there is what? 2 minus. So meaning for us to solve that question, I'm going to do 7.2.1 here. So it will be CR2 and then O7 will be equals to the charge, which we already know there is minus 2. So it's going to be minus 2. If there's no charge here, you put 0. But because I've got minus 2 there, you put minus 2 as the charge. And the aim is to find CR. So CR is being attached to 2. So it will be 2 CR. And then you want to add that with 7 times the group number of oxygen is group number 6, meaning they form negative 2 ions, and then is equals to minus 2 on the charge of the whole molecule. So now just simplify this. This will be 2 Cr, and then 7 times minus 2, that's minus 14. That's minus 14, and then the whole thing will be equals to minus 2 there. So from there onwards, it's going to be 2 Cr, and then the minus 14 will go the other side. So it'll be minus 2 plus plus 14, because the sign will change. So it'll be minus 2 plus 14. So meaning to be 2 Cr, forming negative 2 plus 14 will be 12 now. So then you divide everything by 2, because the aim is to find Cr. So divide by 2, also by 2, because the aim is to find Cr. So therefore Cr will be 12 divided by 2. So Cr will be 12 divided by 2. Just 12 divided by 2, that's 6. And it's positive 6, so it'll be plus 6. That's your answer for Cr there. Yeah, that will be for Cr. Tomorrow they might ask you to find for oxygen. So the same thing will apply. You will do 2 and then you multiply it by the ion of group number of Cr. Then you will add that with 7 times O. Then you go and solve for O. So that is that. Okay. Using the information from the table, okay, table. So I'm going to use the table 4A again. I'm going to use table 4A again. Then write down the balance net ionic equation. Okay, sharp. So let's just get some space there. The aim is to get some space there, but at least I can do this question clearly there. So let me get some space so that I can do this very clearly. Okay, that is fine there. Okay, so from there onwards now we check what's happening. They want us to use the table to find the net balance net ionic reaction. So let's use our table. Okay, clearly indicate the reduction half reaction, the oxidation, and the balance net equation. Okay, so basically we need to go and find the okay, let's start with the reduction first. Let's start with the reduction reaction first. Let's start with the reduction reaction first. So remember, this will be gaining electrons. Let's start with the reduction reaction first. So let's look at this now. Okay, we've got that and that. Okay, I just noticed that Fe might be easy to work with. Okay, before I do this, I'm just trying to break down who's undergoing reduction, who's undergoing oxidation. Because if one is undergoing reduction, the other one will undergo oxidation. So we need to check who's undergoing reduction, who's undergoing oxidation. So let's start with Fe, because on the left we've got Fe 2 plus. On the left we've got Fe 2 plus. On the right side we're having Fe 3 plus. That's what we're getting. So basically we're going from having 2 plus, so they're losing 2 electrons, and then they're losing 3, so meaning they're losing more electrons. So in other words, Fe is losing more electrons, so Fe is undergoing oxidation. Fe is undergoing oxidation. So that's fine. So that makes our life a bit easier. So Fe is undergoing oxidation. So now let's do the oxidation half reaction of Fe. So on the table it's written like this for Fe. On the table for Fe, it's given to us like this. We have got Fe, it's given to us like this on the table. Fe2 plus, Fe2 plus, and then so Fe3 plus on the table, it's Fe3 plus E minus and then that is forming Fe2 plus. That's on the table now. But don't forget, the table that's given to us, it's written in reduction half reaction, and we know Fe is undergoing oxidation. So this reaction here represent a reduction reaction. So meaning it's not correct, because we need to represent one which is undergoing oxidation. So to find the one that is undergoing oxidation, just do the reverse of it. So meaning now, instead of starting with Fe3 plus, we'll begin with Fe2 plus, and then that will form Fe3 plus, and then also plus E on the other side, plus E minus. So this will be the oxidation half reaction that we'll be looking for. This will be the answer that they're looking for. The first one, this one will be incorrect, because this represents a reduction reaction. So it will be incorrect. So don't just be careful tomorrow. If Fe is undergoing oxidation, you must represent an oxidation half reaction. But if Fe was undergoing a reduction, then we'll just copy it straight from the table. But because Fe is losing electrons, therefore it's undergoing oxidation. So that's the oxidation half reaction which they ask us to show. So I've already shown this part already, which they want us to show. So now I need to go and find the reduction half reaction, which makes our life easy now. Because if Fe is undergoing oxidation, therefore the remaining one, which will be Cr2O7, will be undergoing reduction. That's how life can become easy. Once you find out the other one is undergoing oxidation, therefore the other one will be undergoing reduction, because the two must be there present in your redox reaction. You can have a redox reaction that only has one sort of like reaction occurring. It must have both of them. So Fe is undergoing oxidation, so meaning our Cr will be undergoing reduction. So now just go to the table and look in the table where we can find Cr2O7 on the table. So let's go and find Cr2O7 on the table. There we are. Oh, it's a long one. So it's C. I just copied it because it's undergoing reduction. So it's Cr2O7, and then 2 minus, and then plus 14H plus 14H plus. It's gonna be a long one. 14H plus. Just copying it straight from the table now. 14H plus, and then from there onwards, and then it's plus 6E minus, plus 6E minus. I feel like I'm just trying to get some space for this, because I'm not gonna put everything here. The space is so small for me to put everything there. So let me just try and put it down there just to get more space. So the reduction reaction, I'm gonna put it down here so that I can get more space now. So it will be Cr2O7, 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 and then as 2 minus there as a charge, and then plus 14H plus, plus 14H plus, and then plus 6E minus, plus 14H plus, and then plus 6E minus, plus 6E minus, and then that whole thing on the right is forming 2Cr, and then the charge is 3 plus there, it's 3 plus, and then plus 7H2O now. So that's the reduction half reaction, that is there, 6H2O. So I've shown both the reduction half reaction and also the oxidation half reaction. So we need to get the net balance equation now. So you just need to go and find the net balance. So the net balance, you need to go there and first cancel the electrons which are there. So let's check what's happening. Here on the oxidation half reaction, we've got electron S1. But on the reduction one, we've got electrons S6. So first thing first, we need to balance the electrons. We must have at least similar electrons both sides. So for us here, I've got 6 already. For me to also have 6 here, therefore I can multiply the electrons here by 6, so that I can have 6 on both directions. So if I multiply this by 6, therefore now electrons here become 6 electrons. So this one will become like this now. And don't forget, once you multiply electrons by 6, you need to multiply everything by 6. So you need to multiply also this one by 6, also that one by 6, because that will be balancing it out. So meaning now it will come back as like this. I can even put a normal 6. So now it will come back like this, which will be a normal 6. So it will be 6, 6, and then it will be Fe 2 plus, based on me balancing my electrons. So it will be 2 plus there, and then there it will be 6 Fe 3 plus. So it will be 6 Fe 3 plus, and then plus electrons now are 6 because I've multiplied them by 6. 6E minus. That will be me balancing my electrons. And then from there onwards, the first thing to do is to cancel electrons, because the other one's on the left, the other one's on the right. So the electrons will cancel each other. Whatever is remaining on the left side, just copy it as it is. So on the left side, I'm left with 6 Fe 2 plus there on my first one. So it will be 6 Fe 2 plus. Whatever is on the left, just copy it as it is. So it will be 6 Fe 2 plus on the left, then plus more here below we are having Cr2O7 and then 2 minus, and then here we are having 14 plus. They're all on the left side now. 14 H plus, everything on the left. 6E is cancelled, so it won't come back again because it's been cancelled or balanced out. And then on the right side we've got here this one, which is 6 Fe. So you've got 6 Fe 3 plus. So just copy everything that is remaining, and then below here, and then plus, just put plus here. Below here we've got these two which are remaining, which will be 2Cr3 plus, and then also plus 7H2O, then plus 7H2O, 7H2O. So that will be your net equation. So first thing first is to do the half reaction for reduction and also for oxidation. Once you get those two half reactions, make sure that your electrons are the same. If the one on oxidation is having 1 electron, the one also on reduction must have 1 electron. But if the other one is having 6 electrons, the other one is having 1, balance it out, multiply the other one by the same number. Tomorrow you might get one where the one, let's say in oxidation is having 2 electrons, the one in reduction is having 3. So the best thing is to do the LCM, which is to make them all be 6. So if the other one is having 2, you might buy the one which is having 2 by 3. Let me just show you an example quickly. Let's say we've got A, just show you an example quickly. Let's say we've got A. Okay, A is not coming out nice. Just say we've got just use A. Let's just use C. Let's say we've got C here on our reaction, and then plus C plus E minus. Okay, let me just say 2E minus now. 2E minus, and then that is forming CC2 plus now as our reduction reaction. And then here below, let's just have maybe D. That's at a good oxidation, so it'll be D there, and then it will form, just say D 3 plus, D3 plus, and then plus 3E minus now. So for us to find the net of that one, first thing first, check the electrons. Here we've got 2, here we've got 3. So we can't cancel them out because they're not balancing. So if you've got 2 and 3, 2 and 3, the LCM of 2 and 3 can be 6, because it will be 6 the LCM of 3 and 2. So meaning to make them all become 6 electrons. So how do I make electrons? If I've got 2, how do I make them 6? I can multiply everything by 3 to make them 6. I'll multiply everything by 3 to make them 6. So also I'll multiply this one by 3. This one also by 3. The aim is to make them 6. Here I've got 3 electrons. How do I make them 6? I'll multiply everything by 2. Also by 2, because the aim is to make them 6. Once you multiply everything by 3, so therefore, just put a nice color there. So therefore, the one on top there will come back like this. It will be 3C, and then plus 6E minus, plus 6E minus, and that will be forming 3C2 plus. That will be C32 plus there. Then the other one here, because multiplied by 2, it will come back as 2D and then forming 2D, because everything will multiply by 2, so 2D 3 plus there, and then 3 times 2 will be 6, so there'll be 6E minus there. Then for us to find the net, the electrons must cancel each other. So the 6 that is on the right will cancel the one on the left. So whatever is left on the left side, we just add them. So it will be 3C plus 2D on the left. So on the left it will be 3C plus 2D, which we're having on the left side. 3C plus 2D. We're going to have that on the left side. So this one will be 2 plus there, which I just made a mistake. So it will be 2 plus there as an ion. And then here to come back as a normal C. Just cancel that. This will come back as a normal C there because it's undergoing reduction. So meaning so 2 plus will be here. So it will be 2 plus there, and then the other one will be normal without an ion. So the plus won't be there now. Sharp. So meaning this will just come back like that. It will be 3Cu2 plus there, Cu2 plus 2D, and then that whole thing will be adding what's on the right, which is 3C from this one here, and then plus 2D 3 plus. This will be your net reaction for that one. So just be careful that before you do anything, your electrons must be balanced out. So that will be that for that. So let's go to I think just do one more, so at least we can do 2 examples, which will be helpful for you guys. So we've got another question here now, same topic, and then same thing we'll need to apply as well here. So before you can even do anything, again here, before you can even do anything, we're given a redox reaction here. So you need to go and figure out who's undergoing oxidation, who's undergoing reduction. So firstly, let's start with Fe. So we've got Fe 3 plus here on the left side. And then on the right, it's giving us Fe 2 plus on the right now. It's giving us Fe 2 plus on the right. So that's what we're getting now. So you ask yourself, we're going from losing 3 electrons to losing 2 electrons. So we went from losing 3 to losing 2 electrons. So meaning we're losing 3 on the left. On the right, we're losing only 2. So meaning, in other words, we are gaining electrons. So Fe is undergoing reduction because it's gaining electrons, because it's now losing less than what it was losing before. And then the other one was zinc, which is Zn. So Zn on the left, then on the right it's Zn 2 plus now on the right, Zn 2 plus on the right. So now we're going from 0 charge to what? 2 plus charge. So meaning we are losing 2 electrons on the right side. And whenever we're losing electrons, that is what we call oxidation. So zinc is undergoing oxidation. So that's how you're going to find who's undergoing reduction and also oxidation. So now let's go to the questions now, because I already know that Fe is undergoing reduction. Just put Sr now. And zinc, just put So. It's fine. So let's just cancel that so that we can get space for this now. Then they are asking us to define oxidation in terms of electron transfer. Same thing that we did in the previous question. Oxidation is the loss of electrons. That's the loss of electrons. That's oxidation, it's the loss of electrons. So if they ask for reduction, reduction is the gaining of electrons. So loss of electrons, which is loss of E minus, which is electrons. So right down there, again, don't forget, whoever is undergoing reduction, that person is the oxidizing agent. Whoever is undergoing oxidation, that becomes your reducing agent, like the previous question. Now you ask yourself, who's undergoing oxidation? It's zinc. Zinc is undergoing oxidation. Therefore, zinc will become the reducing agent. So meaning zinc becomes the reducing agent because they're undergoing oxidation. Whoever is undergoing reduction, they become the oxidizing agent. So then let's find the reduction half fraction. So who's undergoing reduction? It's Fe. So basically they're asking us to find the Fe reaction on the table. So, and then don't forget the table already, it's written in reduction half reaction. So you go and find Fe 3 plus, just copy it as it is now. Let's go and find Fe 3 plus on the table and copy it as it is. The table name for Fe 3 plus, Fe 3 plus, there we go. So that's Fe 3 plus on the table. So because it's a reduction, just copy it as it is. So it's Fe 3 plus and then plus E minus, and then one arrow when you put them as here fractions, then it becomes Fe 2 plus. That will be your reduction half fraction because F is undergoing reduction. Tomorrow they might ask you for oxidation half reaction, which would have been reaction of Zn on the table, but in a reversed manner because the table is under reduction. 9.2, consider the redox reaction below. We're given a redox reaction now. So first thing first, again, we've got Ag and NO3. So you need to go and figure out who's undergoing oxidation, who's undergoing reduction. So to find that out, just put them down as they are. I know I've got Ag on my left is like that with no charge. And then on the right, it's having Ag plus. So meaning whenever you see plus, we know that it's loss of electrons. So on the left side, it was 0 charge, but on the right, it becomes +1. So meaning Ag has lost 1 electron, in other words. And whenever you are losing electrons, therefore you're undergoing oxidation. So whenever you're losing electrons, you're undergoing oxidation. Then now, by default, okay, just put them down. Ag is undergoing oxidation. So meaning the other one must be undergoing reduction, which will be the gaining of electrons. So that will be that. So now define 9.2.1, define the oxidation number of nitrogen N in NO3 minus. The last to define or determine, not define. I'm saying define. So the last to determine the oxidation number of N in NO3 minus. So first thing first, just copy it down as it is now. So it will be N plus 3, which is multiplying our oxygen. Oxygen is in group number 6, therefore it will form -2 here, and then the whole thing will be equals to minus should be equals to -1 based on that charge. So from there onwards, it will be N 3 times -2, that's -6, and then this side is what, -1. So we need to go and solve for N. So it will be N will be equals to -1, which is already there, plus 6. Then for N will be equals to -1 plus 6, that will be +5 there. So the N was +5 there. So yeah, so if they don't give a charge here on top, just equate everything to 0, and then the number in the bracket you put the ion. If it's group 6, it becomes -2. If it's group 5, it becomes -3. If it's group 1, it becomes +1. Group 2 becomes +2. Group 3 becomes +3, and so on and so on. So that will be that for 9.2.1. So let's do 9.2.2. Determine the chemical equation using the ion electron method. So now we have to use the ion electron method. So same thing will apply. To find the chemical equation, that will be the net. So basically they're asking us to find the net. And don't forget, to find the net, you must have those half reaction first. So the first one you're going to have is the oxidation half reaction, which you already, okay, we know that Ag is undergoing oxidation. So let's go and find Ag on the table. Ag on the table, it's written like this now. Just be careful. Ag on the table, it's written like this. It's Ag plus E minus there, and then the whole thing is forming Ag. That's what Ag is on the table, but that reaction represents reduction reaction. Because Ag is undergoing oxidation, that cannot be our answer. So for us to find Ag that is undergoing oxidation, just go and reverse the reaction on the table. So meaning now we'll start with Ag first, just gonna go ahead and reverse the whole thing. Start with AG first and just solid, and then on the right side it will form AG plus. It will form AG plus on the other side, and then also plus E minus. That will be the oxidation fraction of AG. The one that is given on the table will be for reduction 1. So now let's also find the reduction half fraction, because we need to get the net balance equation. So remember, if this one is oxidation, another one will be undergoing reduction. So let's go and find NO3 in the table. Let's go and find the reduction for NO3. NO3, yeah, there we are. I found you NO3. There's NO3 there, and then minus there, and then this is the same as AQ now. So you just need to copy them as they are. That's aqueous. AQ means aqueous now. Same thing as here. The aqueous solution of NO3, and then from there onwards, it's reaching with 2 plus 2H plus there. I'm just copying it as it is on the reduction table, which I showed you guys at the beginning, and then plus E minus, then plus E minus, and then on the right side that is forming NO2. It's forming NO2, which is a gas there. It's forming NO2, which is a gas, and then water, and then it's forming water as well. So that's the reaction of NO3. So now first thing first, again, you need to balance your electrons. How many are we having this side? It's 1. I don't know, this looks so clumsy. It's plus there. Just looks so clumsy there. So it's going to be plus, that's AQ there. So it's plus E minus now. So we've got 1 electron on the first one, and then on the second one we've got 1 electron. And remember, the other one's on the right side. It's the right side after the sign. The other one's on the left side. So they cancel each other. If the other one is on the right, the other one is on the left. And then whatever is left on the left side, just copy them as it is. So for the net reaction, whatever is on the left, just copy them as it is. So on the left side, you are left with AG. So on the left, we're left with AG, which is solid. So it's AG S on the left, and then plus NO3 minus. So left also with NO3 minus, which is aqueous. That's on the left side. Also, we've got 2H plus on the left side, 2H plus on the left side, and then on the right side, so then we're going to put the arrow. On the right side, we've got AG plus there. So we've got AG plus there, which is that AG plus, and then also on the right here, we've got NO2. So just copy them as they are, since we didn't have to balance our electrons. NO2 there, that's AQ, and don't forget to put those things. Yeah, they're very important. Some teachers are going to be strict, because sometimes I forget to put them. Don't be like me when you guys are putting them. Then lastly, we've got water. Lastly, it's H2O now. Lastly, it's H2O. That's like water there, and that's going to be like your water. So that would be your net balance or net balance equation, which will represent the chemical equation of the reaction. So the net will represent the chemical equation. So that should be your answer. So firstly, you do the oxidation reaction, and then you do your reduction one, and then if your electrons are same number, you cancel them out. Then wherever is on the left, you copy them as they are, same as whoever is on the right after the arrow. That will be your answer for that. So I hope the 2 examples I've done will help you guys in this topic of redox. And then for those ones who are new here, check my playlist. I've done other practice questions for other topics in grade 11 physical science. So please check them. And if there's another topic that doesn't make sense to you guys, comment on the comment section. I will try and cover it as much as possible. And hopefully this will help you guys as you're preparing for the November exams, which are coming very soon. So see you guys on the next lesson. Thank you very much.